Today's lab, electromagnetic induction, lab 9. Okay, here all the apparatus, equipment you will be needing to do the experiment, and your lab will be posted in Blackboard with your lecture notes. So don't worry, you can go there. I have not posted it yet, but I'll do it today. Okay, and let's start. The equipment list. Okay, pair of insulated cylindrical coils. We're talking about this, and core rods, iron, aluminum, and insulating object in this case is a wood. Pair of magnets, compass, knife switch, galvanometer, connecting wires, meter sticks, ruler, graph paper, and the power supply. Now we'll take a pause and I'll set up the experiment and do. By the way, this is electromagnetic induction. Basically, if an electric field change, right? Like if you connect with the power supply, and if I do this, that means you're changing the electric field going through a circuit. It will produce magnetic field and vice versa. Okay, and magnetic flux, electric flux, you learn already in the lecture. So today's experiment, we are ready to do. Thank you. Okay, for experiment, page 6 data table, and here look, you have the galvanometer, you have a primary coil connected, you have a magnet. Okay, to show you induced current, let's say I have a weak magnet. Okay, and if you pay attention here, okay, so this experiment in your page 6, induced current with a weak magnet, and look at the deflection. See, look, slow. If you go faster, right? So if you look at the V2 is greater than V1, okay? Motion away from the coil, watch. Okay, and then magnet 2, a stronger magnet, okay? Because it will be faster. Look at, please attention here. Okay, so as you can see, this motion depends on how fast you are changing the field. Okay, and also it depends on how strong the magnet. Okay, so if you do the experiment, and your data will be as follows. Right away, we're going to take a shot of the data table, which I did. Here. Which is a repeat of the first experiment, Lange's law. Just to show you the direction, let me explain. If you do the experiment, if the magnet is going into the coil, if the deflection is to your right, when it is coming out from the magnet, deflection, it will be to your left. Follow? If you want me to show, it's the same what you observed in the previous experiment, but for clarity, let me do it again. Look, please observe here. Let's concentrate here. Look, it's going in. Look, coming out. Look, and by the way, this is Lange's law. Okay. Thank you. Let's go to the next part of the experiment. Part D. If you look at your lab report, called permeability, and look at the circuit is connected. Look at galvanometer, switch goes back to the galvanometer. Now watch as I do this. Please. I'm going to. Oh. So it's switch, okay, and now you're going to use, different core. Okay, so let's do it this way. Now watch. I'm giving you first is air core. This is just air, and if you look at the deflection, it will not be much. Okay, let me. Too much. Okay, just air core. Now if you put an aluminum, same almost, because aluminum is also not magnetic. But if you put steel or iron, it is too much. Okay?
Okay.
And if you look page 7, okay? So switch closed, right? Galvanometer deflection, okay? Which way, okay? Positive or negative, okay? And iron core, okay? This is iron core, and this is aluminum core, okay? And just your observation, okay? Going positive direction or negative direction. Okay, so this part is done. Now you have the last part of the experiment. The setup is the same, okay? And now you have this secondary coil, okay? And this has coil, right? How many loops here? How much, look, maximum, minimum. So that's all in your data table. You measure it, okay? So this is, let me do it for you. If you take a ruler, this is, you know, let me do it in centimeter. So this is like, let's 10, you know, like, yeah, 10.5, okay, total length, okay? So now you put all the way, okay, and then I'm going to show you, and this data table will be posted for you, will be, okay? It will be available in Blackboard, okay? So here, so first if you look at, you know, look, perfect, okay? So the way it is set up, when it is here, the deflection is 50 divisions, okay? Now if I go a little bit off, pull it out, look, so it's like 4D, okay? So if continue you pulling it out, okay, so the deflection level goes down, and I've already collected this data, okay, and I demonstrated how to take this data. If you do that, this is the data table you will produce, okay, and it will be posted to you. All you have to do, this graph, okay, you have length, okay, in centimeter, length of this, okay, so its total length is, when I put all the way, it is 10.5 in your data table, okay? So we pulled it out, okay? And on the y-axis, it will be the deflection, okay? Deflection from 0 to 50. The first one was 50. We adjusted, remember? Okay? So that data table will be produced. So you plot it and you produce a straight line graph, okay? So from this experiment, all the data table will be provided. I hope you learn how to do the experiment, okay? And you graph it and answer all the questions, okay? Write a conclusion, as you know from your other labs, okay? Then you are done, okay? Thank you.